Okay, so this is either the video where you go, oh my gosh, science is amazing and everything is mathematically consistent, or you go, yeah, duh, I could have figured that out on my own. So we'll see what happens. Okay, so we know that angular acceleration is d omega dt. Now, a long, long time ago, like weeks ago at this point, we had a similar equation, a equals dv dt. And we made an assumption where we said, let's pretend acceleration is constant, because a lot of times, like, gravity is constant. So we're going to do the same thing. Let's assume angular acceleration is constant. Okay, so we have alpha dt equals d omega. Integrate, integrate. We're going to start time equals 0 to time equal t from some unknown starting velocity, angular velocity of final velocity. And since angular acceleration is constant, it can come out of here. And on the left, we end up with or alpha, t minus 0, and omega 2 minus omega 1, also known as omega 2. Did I do that right? Yeah, my brain is not working. Omega 2 equals alpha t plus omega 1. And maybe, if your brain is still functioning, which it, to be fair, may not be, and that's okay. Who needs a brain? We're just doing physics. Meow, 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 0t, meow, v1, v2, and see how we got this a t minus 0. Whoa, whoa, dude, check it out. This is amazing. Or not, but it could be really cool. Look, it's basically the same thing, but in roundy rounds. So this is lefty righties and uppy downies, and this is roundy rounds, and it's basically the same equation. It's so fantastic. I love science and math so much. Okay, we're going to do the same thing again, where we do that omega, come here girl, omega is equal to d theta dt. Okay, that was a weird dt. Okay, but I know alpha t plus omega 1, like some initial omega. I think your book likes omega naught. So omega 1 equals omega naught, in case that bothers you. I'm just making it the initial one. dt equals d theta, and we're going to integrate from theta 1, or I guess theta naught, to theta, and then from 0 to t. And on the left, are you just going to be like so shocked when we get 1/2 alpha t squared plus omega naught t? And on the right, theta minus theta naught. And then when we fix it, we get theta equals 1/2 alpha t squared plus omega naught t plus theta naught. And the crowd goes wild. Maybe. I'd like to hope so, because it's this thing, right? Yay! Look, it all is mathematically consistent. And you know what else we can do? We can take the alpha equals d omega dt and put it over omega equals d theta dt. And from there we can get alpha over omega equals d omega dt divided by d theta dt. And then the dt's cancel out, and we end up with alpha over omega equals d omega d theta, also known as alpha d theta equals omega d omega. And if alpha is constant, and we integrate, then we have alpha theta minus theta naught equals 1/2 omega squared, evaluated here to here. And we've got, if I put the 2 over here and I do some fun math, I get omega squared equals omega naught squared plus 2 alpha delta theta, which is literally just this thing. And you're like, ugh, I thought I was away from that, and no, you're not, because it's amazing, and science is fantastic. So I don't know how you could ever just not be deeply satisfied on a fundamental level with how this works. Okay. Anything else that we super duper need to go over? I think the biggest things that you need to be worried about in stuff like this is, making sure you know what the circumference of a circle is. And then whenever they talk about revolutions per second or something like that, just remember a revolution is a full circumference. So a revolution is 2 pi radians per second. Now, radians isn't officially a unit. It's considered a unitless measurement. So I could say it's 2 pi per second is the rotationiness. But sometimes if you're given something in revolutions, you're going to need to convert it to radians. Or if you're given something in theta, like in degrees, you need to convert everything to radians. So we are now officially in, for the purposes of rotation, everything gets converted to radians territory. Okay, so let's just look at this one. So fisherman hooks a big fish, good for him, that swims away, pulling the line. So much drama. The whole system is initially at rest. The fishing line unwinds from the wheel a radius of 4.5 centimeters from its axis of rotation. Oh, like in the picture. I was trying to figure out what they were talking about. The reel is given an angular acceleration of 110 rads per second squared for 2 seconds. What is the final angular velocity? Well, hot potato. So I know that the final angular acceleration is given by alpha t plus omega naught, because that's just like final velocity equals at plus v naught. It's the same thing. So 110 radians per second squared times 2 seconds plus it's initially at rest. So isn't that just 220? Why am I? Okay, yeah. Okay, I'm not going crazy. How many revolutions does it make? Okay, so this is maybe more interesting. So it goes 1/2 alpha t squared plus omega naught t plus initial theta, but it's originally at rest, and let's just say the initial theta is 0. So the theta that it goes through is 1/2 110 t squared. So we have 110 t squared divided by 2. I guess I probably could have done that in my head. Is 220 again. Thank you for giving us the same number twice. That's really, really nice. 220. So this is 220 radians, and it asks for how many revolutions. And you know that 1 revolution is 2 pi radians. So there's other ways to do it, but I like to learn one way and, never learn anything else in my life. That's been always my big goal. So I just treat it like a unit conversion. So I'm going to cancel out the radians, and I end up with revolutions on the top. So 220 over 2 times, and what I do is I forget to put the 2 pi in parentheses, and then I get the answer wrong. Thank you. Why did I put a period there? No reason. I'll put a period here. Okay. All right, so 35.0. So theta is 35.0 revolutions. So it runs 35 times around. Kind of makes sense? Okay. And then, these are all the same kinds of problems. It's just like instead of going lefty-righty and uppy-downy, you're going roundy-roundy. And I think if you just make that connection, these problems are relatively straightforward, but just making sure that you remember how to do this conversion and don't get in your own way. As long as acceleration is constant, you can use these beautiful, wonderful, perfectly lovely equations that we came up with over here. So as long as everything is constant, as long as angular acceleration is constant, we can use this one, we can use this one, and we can use this one. That's pretty fabulous.